Launch Director.
Launch vehicle is ready for launch.
Mission Director.
3,
You have permission
2.
to launch.
We have ignition of the RS-68A main engine. And we have liftoff of the United Launch Alliance Delta IV Heavy rocket.
Mach 1 executed, and we have indication of spacecraft separation.
At Space Launch Complex 37, a Delta IV Heavy rocket is fueled and ready to launch the NROL-44 mission for the National Reconnaissance Office. Good morning. I'm Dylan Rice, a Systems Test Engineer, Launch Conductor, and your host for today's broadcast. T0 is set for 2:04 a.m., and the launch team is working one issue that may push us into the window. A few seconds from now, at T-minus 4 minutes, the launch count will enter a planned 15-minute hold. We have 2 planned holds in today's 9.5-hour launch count. These planned holds give our team additional time to resolve any issues that come up prior to entering terminal count. At the request of our customer, today's live coverage will conclude following payload fairing jettison, scheduled to occur about 6.5 minutes after liftoff. In addition to watching our webcast, you can follow live mission progress at ulalaunch.com. Will Ulrich, the 45th Space Wing's Launch Weather Officer, recently briefed the team on weather conditions here at Cape Canaveral. The probability of violating launch constraints is 10%.
The temperature issue is being
Ground winds are
referred
5
to
to 10
Anomaly
knots out of the
Chief Dave
southwest, and the
McFarlane for
temperature is 81
discussion.
degrees
Any
Fahrenheit.
troubleshooting steps.
So the weather is within
resolution.
launch commit criteria and looks favorable for our planned T0 at 2:04 a.m. Eastern. Today's flight will take an easterly heading away from our Cape Canaveral launch pad. Let's take a look at what else we can expect to see this morning.
And liftoff of the United Launch Alliance Delta IV Heavy rocket.
At T-minus 14 seconds, the ROFIs, which look like sparklers, ignite to burn off excess hydrogen injected into the flame duct. ROFI ignition is followed by ignition of the starboard Delta IV RS-68A engine at T-minus 7 seconds. 2 seconds later, the center and port RS-68A engines ignite, generating more than 2.1 million pounds of total thrust to lift the rocket off the pad. This staggered engine start mitigates the fireball created by the hydrogen-burning Delta IV Heavy. Shortly after liftoff, Delta IV begins a pitchover to attain the proper flight path, while minimizing the pressure the vehicle experiences during flight. The Delta IV reaches Mach 1, the speed of sound, at 1 minute 18 seconds. 2 seconds later, the rocket experiences maximum dynamic pressure as it travels through Earth's atmosphere. At 3 minutes 56 seconds, the port and starboard booster engines shut down. 2 seconds later, the port and starboard boosters are jettisoned. The center booster engine then throttles to full power to maximize performance. Approaching main engine cutoff, Delta IV is traveling at more than 24,753 kilometers, or 15,381 miles per hour, is located 111 kilometers or 69 miles in altitude, and is 586 kilometers or 364 miles downrange. At 5 minutes 36 seconds, propellant levels deplete and the booster engine shuts down. 7 seconds later, the Delta IV separation system activates to release the first stage. The vehicle now weighs a little more than 5% of what it did at liftoff. At 5 minutes 56 seconds, the Delta cryogenic second stage main engine burn begins. During ascent, NROL-44 is protected inside a 5-meter diameter tri-sector payload fairing. At approximately 6 minutes 38 seconds, the payload fairing is jettisoned. Delta IV continues its national security mission following payload fairing jettison.
ULA is using the Delta IV Heavy configuration to launch the NROL-44 mission. This is the 12th Delta IV Heavy launch and ULA's 141st mission. Delta IV Heavy is built in Decatur, Alabama, and it's our largest, most powerful configuration. It's comprised of 3 common booster cores, each powered by Aerojet Rocketdyne RS-68A engines, and a Delta cryogenic second stage powered by an Aerojet Rocketdyne RL-10B2 engine. It's equipped with a 5-meter payload fairing, which you can see here. Events began July 27th when the spacecraft, encapsulated inside that payload fairing, was transported to the Mobile Service Tower at Space Launch Complex 37 and vertically integrated to the Delta Heavy rocket. About 6:30 p.m. last night, final preps began. The Delta Mobile Service Tower is 300 feet tall, 100 feet wide, and 100 feet long, making it as tall as a football field is long and as wide as a basketball court. It weighs about 10 million pounds. There are 40 hydraulic cylinders at pressures nearing 3,500 psi that raise the MST 8 inches prior to moving it back to its park position. The MST uses a carriage transporter system. It travels about a quarter mile per hour and takes about 25 minutes to roll the MST to the launch position 345 feet north of the launch vehicle. Delta IV stands 235 feet tall, or about 23 stories, and weighs about 1.6 million pounds fully fueled. The 3 big RS-68A engines produce more than 2 million pounds of thrust at liftoff. Today's launch is for the National Reconnaissance Office, or NRO. This is ULA's 29th launch for the NRO and the 8th use of the Delta IV Heavy for the NRO. The NRO is a joint organization engaged in the research, development, acquisition, launch, and operation of innovative overhead reconnaissance systems necessary to meet the needs of the intelligence community and the Department of Defense. The NRO is recognized for its transformational intelligence collection systems that are used to develop highly accurate military targeting data, support international peacekeeping and humanitarian relief operations, and to assess the impact of natural disasters. Earlier this week, we had the chance to hear from the L-44 trajectory engineer, Corey Buckingham. Let's take a look at what he mentions is unique about the Delta IV Heavy and today's flight.
Hi, my name is Corey Buckingham. I'm the trajectory engineer for the L-44 mission. There's a few reasons the Delta IV Heavy is the only vehicle that can launch the L-44 payload. Primarily, it's the payload fairing. The ULA payload fairing is 65 feet long and 5 meters in diameter. That's about 16.5 feet. And it provides sufficient payload volume capacity for the L-44 satellite. The performance capability is the combined performance of the first stage and the second stage. As you can clearly see, there are 3 boosters that provide over 2 million pounds of thrust to lift the vehicle off the pad. It's going to be a brilliant show. I can't wait to see it. Now, talking about the second stage, the DCSS, the Delta Cryogenic Second Stage, is a very capable and highly performing second stage. A big contributor to the second stage performance is the extendable nozzle of the DCSS. We launched the mission with the nozzle in the stowed position, and then after booster jettison, the nozzle deployment system extends the nozzle to its full length. This very long nozzle is a huge performance increase because of the increase in ISP, specific impulse. ISP is how we measure the efficiency of a rocket engine. It is calculated as thrust divided by the flow rate of the propellants. A great way to think about ISP is related to your car. Your car's engine, the efficiency is measured in miles per gallon. It's a very similar concept with rocket engines, and the high ISP allowed for by the extendable nozzle of the RL-10 allows us to achieve the orbit of the L-44 payload. So if you're looking for someone to blame for the very early launch time, you can blame me. I'm the trajectory engineer, so I'm responsible for publishing the launch period. So how do we calculate the launch period? The time of launch is driven by the RAN, R-A-A-N, right ascension of the ascending node. The RAN is essentially a sun relative angle that the spacecraft requires us to achieve at spacecraft separation. So once we have the trajectory designed, the knob that we have to turn is the launch time. So we set the launch time to achieve the correct RAN. But then if you stop there, you have an instantaneous launch period. We want as long a launch period as possible to give us the best chances of launching on any given day. For L-44, we have a nearly 5-hour launch period. So how do we get there? trajectory design incrementally steps out the trajectory until we reach the window open and window close time. That duration defines the launch period. Now, these edge trajectories, they need to steer more and use more performance than the window optimal case in order to achieve the same orbit targets. We load specific guidance and navigation parameters depending on when we launch within the launch period so that robust guidance algorithms can get us to the correct orbit no matter when we launch within the launch period. This is just another factor of how the Delta IV Heavy can support the L-44 payload. Personally, I've been working on the L-44 mission for almost 4 years now, so I'm very excited to see all of our hard work come to fruition when it lifts off into the night sky. But more importantly, I'm looking forward to this vital asset to get on orbit and begin supporting the U.S. intelligence community, supporting national security space, and keeping Americans safe.
As I mentioned at the open of the broadcast, the team is working one issue. They're analyzing a temperature in one of the vehicle compartments, and so we are going to be extending this built-in hold until we have further information. As they do for every mission, the NRO provided unique artwork for NROL-44. Here's the story behind the art. The background of this artwork is a dark shade of NRO blue to symbolize cross-organization collaboration required for mission success. In the foreground, we see a wolf howling as a warning to its pack as the first point of detection for signs of trouble. The wolf pack represents the nation and the international community leveraging and supporting the steadfast sentry. Lastly, the falling snow represents the purity of the NRO's intentions and the serene calm of peace. A few moments ago, Mission Director Colonel Chad Davis remembered our friends and colleagues, Chuck Mitchell and Winnie Payne. Let's listen in.
This morning's NROL-44 launch is dedicated to the memory of Chuck Mitchell and Winnie Payne. Chuck and Winnie have dedicated
Though
countless
first
hours
launched in
to
1960, Delta's
technical
story
expertise,
really begins in the
ensuring the incredible
mid-1950s
success
with the
of a
development of
multitude
the
of
Thor
launches.
intermediate
Their
range
warm
ballistic
smiles,
missile.
team spirit, and phenomenal leadership have rippled across the aerospace and launch communities. To our fellow patriots, rest in peace.
LC on 1 AC.
Go AC.
Okay, we have yet another ECS adjustment for you. This is for the inner tank. Currently it's 70 degrees F. We want to take that to 80 degrees F.
Roger. ECS LC.
Go.
Please take inner tank from 70 degrees Fahrenheit to 80 degrees Fahrenheit.
Roger.
Really begins in the mid-1950s with the development of the Thor intermediate range ballistic missile. Named after the Norse god of thunder, Thor was created in response to a growing fear that the Soviet Union would beat the U.S. in the deployment of a long-range ballistic missile. The goal was to design a system that could deliver a nuclear warhead to a target 2,300 miles away, the distance between the United Kingdom and Moscow. On January 25, 1957, the first Thor lifted off from the newly constructed Space Launch Complex 17 at Cape Canaveral. Following a series of early failures, the Thor team celebrated their first success on September 20th, 1957. In all, 59 Thor IRBMs were launched, with the last flight occurring in 1975. Thor began the transition from missile to space launch vehicle in 1958. On October 11, 1958, America's newly formed space agency marked its inaugural launch when Thor Able boosted NASA's Pioneer 1 on a mission to the moon, and NASA's long partnership with Thor was born. NASA and the Douglas Aircraft Company began development of the fourth and longest-lasting Thor configuration in April 1959. Using a Thor first stage and a Vanguard second and third stage, Delta I lifted off on May 13, 1960 from Cape Canaveral Space Launch Complex 17. Though its first launch was not successful, the Delta team quickly pinpointed the failure and 3 months later delivered NASA's Echo 1 communication satellite to orbit. Following Echo 1, the Delta team racked up an impressive 22 successful launches. Led by Bill Schindler, the Delta rocket earned
This is Delta
its
Mission
industry
Control at
workhorse
T-minus 4 minutes and holding.
rapidly
We remain in
establishing
the planned
itself as
built-in
one of the most
15-minute
reliable
built-in
and
hold as
versatile
preparations for
launchers.
launch continue.
During the 1960s,
The team is still
Delta
working
launch
through the
vehicles
temperature
paved
issue I
the way
mentioned
for the
earlier.
burgeoning
We'll get back to you
communications
in
industry,
T0 as soon as
launched
we can.
America's first weather satellites, and sent probes to explore our universe. AT&T's Telstar 1, the first commercial communication satellite, launched in 1962. And in 1963, SYNCOM-2 became the world's first geosynchronous satellite. TIROS, or Television Infrared Observation Satellites, provided the National Weather Service with humans' first view of the Earth's cloud cover. In orbit around the Earth, Moon, and Sun, NASA's Explorer satellites provided us with a deeper understanding of the solar wind, cosmic rays, as well as Earth's magnetic field and radiation belts. By the end of the decade, launch vehicle modifications, including the addition of solid rocket motors and an upgraded third stage, made it possible for Delta to orbit satellites 10 times larger. The 1970s was an international decade for Delta, as the manifest included scientific and communication satellites for several countries across North America, Europe, and Asia. Perhaps the most demanding challenge of the 1970s was the launch of the Earth Imaging Earth Resources Technology Satellite, later known as Landsat. The mission for the Earth Sciences community required major changes to the Delta propulsion and guidance systems. During the 1980s, Delta continued its reliable service to the communications, weather, and Earth imaging communities. As capable as the Delta rocket proved to be, production came to a halt in the early 80s when national space policy dictated that the space shuttle be used as the U.S.'s primary launcher, signaling the end of the expendable launch vehicle. But in 1987, the Delta team picked up where they left off, and development began on a launch vehicle to support the Air Force's Global Positioning System. On February 14, 1989, Delta 184 began a new chapter in space launch history as it lifted off from Space Launch Complex 17, demonstrating an incredible feat. The Delta II had gone from development to launch in just 2 years. To accommodate the larger GPS satellites, engineers improved the Delta rocket in several ways. The fuel tanks were stretched, a new payload fairing was developed, and larger solid rocket motors were incorporated. The modifications resulted in increased performance and flexibility. By the mid-1990s, the Delta II had delivered the fully operational 24-satellite GPS constellation. And though it was developed for the Air Force, Delta again became a reliable partner to both NASA and its commercial customers. Over the course of its more than 20-year run, the Delta II has launched some of America's best-known scientific and exploration missions.
+4, 3, 2, we have main engine start, 0, and liftoff of the Stardust spacecraft. Liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
Liftoff of the Delta II with Grail. journey to the center of the moon.
On the commercial side, Delta II launched the Global Star and Iridium constellations, which brought satellite telephone communication to the world. Continuing its evolution to meet the growing demands of its satellite customers, the Delta team developed the more powerful Delta III. Though short-lived, the Delta III doubled the performance of the Delta II.
Ignition and liftoff of the Boeing Delta III rocket.
Stage systems looking normal. Engine burners keep burning normally, and all sections ground.
In partnership with the Air Force's evolved Expendable Launch Vehicle program, the Delta team began development of the next generation Delta rocket in the mid-1990s.
And we have liftoff of the first Boeing Delta IV rocket carrying the W5 telecommunications satellite for Eutelsat of France.
All Delta IV configurations begin with the Common Booster Core, powered by the RS-68A main engine. The Delta IV Heavy, with its 3 Common Booster Cores, deliver our nation's largest missions to orbit.
Liftoff of the United Launch Alliance Delta IV Heavy rocket carrying the NROL-44 mission for the National Reconnaissance Office.
Delta IV launch vehicles are produced at a 1.5 million square foot state-of-the-art facility in Decatur, Alabama. Processing and launch takes place at Space Launch Complex 37 at Cape Canaveral Air Force Station and Space Launch Complex 6 at Vandenberg Air Force Base in California.
Range safety arm light on. Right.
Affirmative.
Range ready.
Ready.
Water system ready.
From its early beginnings as a weapon and deterrent, through its transformation into a space launch vehicle, Delta has reliably supported our nation for more than 60 years. Delta's legacy as a workhorse continues today and is a testament to the persistence, dedication, and commitment of an enterprising team that has continually evolved the Delta rocket to support a changing world.
5, 4, 3, 2, 1, and liftoff of the United Launch Alliance Delta IV Heavy rocket.
Achievements on the ground, where analysts bring it all together. How do we do it? By investing in the latest research and development, using augmentation, automation, machine learning, and artificial intelligence, employing acquisition strategies to encourage competition, enabling us to work with the industry's best and brightest, like-minded people, committed to technology without limits. This is where careers rise to heights unimagined, where you can take your eyes and ears into space. We deliver, under budget and on schedule, meeting and exceeding expectations, to answer questions yet unasked. We develop new technologies every day and put them to use in record time in the high ground of space. No one can match us. The National Reconnaissance Office, the world leader in intelligence gathering. We are the NRO.
While the team continues to evaluate the issue and evaluate our new potential T-zeros, one of the other items that the team will be reviewing is data from the wind balloons that are launched from here at Cape Canaveral Air Force Station. Data from these balloons are used to generate a steering profile for the first 115,000 feet of flight. These balloons provide data on wind, temperatures, etc. that we use to design the pitch, yaw, and roll steering profile for early ascent. This steering profile is loaded onto the flight computer 30 minutes before launch and can be updated within the launch period if our launch time is delayed. We have this capability on all configurations of our vehicles because it allows us to minimize the effects of wind shear, which reduce dynamic loads on the vehicle and spacecraft, and provides for more launch availability during periods of strong upper-level winds.
I'm Tori Bruno, President and CEO of United Launch Alliance. You are about to see the first ever 3D animated projection on an operational rocket. And of course, we have chosen the majestic Delta IV space launch vehicle for this experience. So enjoy the show and God bless America.
We are dreamers, inspired by possibilities not yet imagined. Believers, driven to harness the potential of space. Leaders, combining expertise and ingenuity. And it all started with a spark of the imagination.
Go. Timer. Go. ECS. Go. QE. Go. USO. Go. OSM. Go. BSE. BSE is go. ALC. Go. AC. AC is go. RC. Clear to proceed. Launch Director. The launch vehicle is ready to launch. Mission Director. You have permission to launch.
10, 9, 8, 7, 6, 5, 4, main engine ignition, 2, 1, and liftoff! Liftoff of the United Launch Alliance DeltaIV rocket.
Although ULA's focus is on the future, we will always celebrate our incredible legacy. 140 missions, 140 successes, enabling our customers to save lives, explore the universe, and connect the world. From John Glenn, the first American to orbit the Earth, to new ways of connecting the world. From the most accurate weather satellites ever deployed.
Mandatory evacuation for Central Florida.
game-changing national security satellites. And launching missions throughout the solar system and beyond. To once again, sending astronauts to space from U.S. soil. And doubling down on our commitment to our country. America has always and will always be at the forefront of space. This mission is no different. As we prepare to launch another critical asset to protect our way of life. The National Reconnaissance Office. When our country needs eyes and ears from the high ground of space, to give advanced warning to threats, to aid in the aftermath of natural disasters, to answer our most pressing intelligence questions. It turns to the National Reconnaissance Office. The leader in national space intelligence systems. Over the next decade, ULA will continue to protect life on Earth with the introduction of the Vulcan Centaur. Our next generation rocket. A rocket purpose-built for national security. Founded on the Atlas and Delta legacy of success. With Vulcan Centaur, we are engineering limitless possibilities for a safer, more secure existence at home and in space. We are dreamers, inspired by possibilities not yet imagined. Believers, driven to broaden horizons. We deliver progress above. And Moscow. On January 25th, 1957, the first Thor lifted off from the newly constructed Space Launch Complex 17 at Cape Canaveral. Following a series of early failures, the Thor team celebrated their first success on September 20th, 1957. In all, 59 Thor IRBMs were launched, with the last flight occurring in 1975. Thor began the transition from missile to space launch vehicle in 1958. On October 11, 1958, America's newly formed space agency marked its inaugural launch when Thor Able boosted NASA's Pioneer 1 on a mission to the moon, and NASA's long partnership with Thor was born. NASA and the Douglas Aircraft Company began development of the fourth and longest-lasting Thor configuration in April 1959. Using a Thor first stage and a Vanguard second and third stage, Delta I lifted off on May 13, 1960 from Cape Canaveral Space Launch Complex 17. Though its first launch was not successful, the Delta team quickly pinpointed the failure and 3 months later delivered NASA's Echo 1 communications satellite to orbit. Following Echo 1, the Delta team racked up an impressive 22 successful launches. Led by Bill Schindler, the Delta rocket earned its industry workhorse moniker for rapidly establishing itself as one of the most reliable and versatile launchers. During the 1960s, Delta launch vehicles paved the way for the burgeoning communications industry, launched America's first weather satellites, and sent probes to explore our universe. AT&T's Telstar 1, the first commercial communications satellite, launched in 1962, and in 1963, SYNCOM-2 became the world's first geosynchronous satellite. TIROS, or Television Infrared Observation Satellites, provided the National Weather Service with humans' first view of the Earth's cloud cover. In orbit around the Earth, Moon, and Sun, NASA's Explorer satellites provided us with a deeper understanding of the solar wind, cosmic rays, as well as Earth's magnetic field and radiation belts. By the end of the decade, launch vehicle modifications, including the addition of solid rocket motors and an upgraded third stage, made it possible for Delta to orbit satellites 10 times larger. The 1970s was an international decade for Delta, as the manifest included scientific and communication satellites for several countries across North America, Europe, and Asia. Perhaps the most demanding challenge of the 1970s was the launch of the Earth Imaging Earth Resources Technology Satellite, later known as Landsat. The mission for the Earth Sciences community required major changes to the Delta propulsion and guidance systems. During the 1980s, Delta continued its reliable service to the communications, weather, and Earth imaging communities. As capable as the Delta rocket proved to be, production came to a halt in the early 80s when national space policy dictated that the space shuttle be used as the U.S.'s primary launcher, signaling the end of the expendable launch vehicle. But in 1987, the Delta team picked up where they left off, and development began on a launch vehicle to support the Air Force's Global Positioning System. On February 14, 1989, Delta 184 began a new chapter in space launch history as it lifted off from Space Launch Complex 17, demonstrating an incredible feat. The Delta II had gone from development to launch in just 2 years. To accommodate the larger GPS satellites, engineers improved the Delta rocket in several ways. The fuel tanks were stretched, a new payload fairing was developed, and larger solid rocket motors were incorporated. The modifications resulted in increased performance and flexibility. By the mid-1990s, the Delta II had delivered the fully operational 24-satellite GPS constellation. And though it was developed for the Air Force, Delta again became a reliable partner to both NASA and its commercial customers. Over the course of its more than 20-year run, the Delta II has launched some of America's best-known scientific and exploration missions.
+4, 3, 2, we have main engine start, 0, and liftoff of the Stardust spacecraft, liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
Liftoff of the Delta II with Grail. Journey to the center of the moon.
On the commercial side, Delta II launched the Global Star and Iridium constellations, which brought satellite telephone communication to the world. Continuing its evolution to meet the growing demands of its satellite customers, the Delta team developed the more powerful Delta III. Though short-lived, the Delta III doubled the performance of the Delta II.
Ignition and liftoff of the Boeing Delta III rocket.
Stage systems looking normal.
In partnership with the Air Force's Evolved Expendable Launch Vehicle program, the Delta team began development of the next generation Delta rocket in the mid-1990s.
And we have liftoff of the first Boeing Delta IV rocket carrying the W5 telecommunications satellite for Eutelsat of France.
All Delta IV configurations begin with the Common Booster Core, powered by the RS-68A main engine. The Delta IV Heavy, with its 3 common booster cores, deliver our nation's largest missions to orbit.
Liftoff of the United Launch Alliance Delta IV Heavy rocket carrying the NROL-44 mission for the National Reconnaissance Office.
Delta IV launch vehicles are produced at a 1.5 million square foot state-of-the-art facility in Decatur, Alabama. Processing and launch takes place at Space Launch Complex 37 at Cape Canaveral Air Force Station and Space Launch Complex 6 at Vandenberg Air Force Base in California.
Range safety arm light on. Right. Affirmative. Range ready. Ready. Water system ready.
From its early beginnings as a weapon and deterrent through its transformation into a space launch vehicle, Delta has reliably supported our nation for more than 60 years. Delta's legacy as a workhorse continues today and is a testament to the persistence, dedication, and commitment of an enterprising team that has continually evolved the Delta rocket to support a changing world.
5, 4, 3, 2, 1, and liftoff of the United Launch Alliance Delta IV Heavy rocket.
This is Delta Launch Control at T-minus 4 minutes and holding. The team continues to work through a lower than expected temperature condition in one of the vehicle compartments and has not selected a new T0 at this time. No matter when we lift off within the launch window, the trajectory is fixed through payload fairing jettison. A fixed ascent profile makes the range safety analysis more straightforward because areas that are clear do not have to change if the launch times move within the launch window. Robust guidance algorithms make corrections later in the mission in order to achieve the target spacecraft orbit. These guidance algorithms account for all the mission constraints, which could be structural or thermal, for instance, how long the spacecraft spends in the sun, and adjust the duration of each of the 3 main engine burns to ensure that the spacecraft arrives where our customer wants it on time. This is Delta Launch Control at T-minus 4 minutes and holding. The team continues to work through a thermal observation in one of the vehicle compartments that does not match pre-launch predictions. And we are awaiting a new T0. Whenever we have issues like this come up, the Anomaly chief, who you will hear polled in the final countdown, will form a team comprised of ULA engineers, both here at the launch site and, if required, back at our design center in Denver, Colorado, to talk through the issue. As part of that team, the United States Space Force has engineers represented in that conversation as well. And if it's an issue that comes up and could potentially impact our spacecraft, the spacecraft team is invited to participate in that discussion also. During that discussion, the team will work through current observations and potential troubleshooting steps if required. The entire team will concur on a go-forward plan that will allow the launch to proceed or provide additional data with respect to the given condition. And once the entire team agrees, the team will either proceed with the count or proceed with troubleshooting as prescribed by the Anomaly team. Once the issue is resolved, the Anomaly chief will come to Net 1 and provide an outbrief to the launch director and the mission director and the launch conductor, indicating that the condition has been resolved and operations can proceed for launch. So we'll continue to stand by while the team talks through the thermal concern, and we'll provide updates as they're available.
Go, LD. LC, at this time, please load new target set, segment Bravo. Roger. Flight control, LC, Net 1.
This is flight control.
First step 1450. Load contingency trajectory using autofile FPCS D Delta Victor 041-002 _ Charlie Alpha Sierra Echo _ Bravo. And revised guidance STL CRC is 5 Delta Charlie 8.
Roger. And work.
This is Delta Launch Control at T-minus 4 minutes and holding. As you just heard, the launch conductor gave the order after direction from the launch director to update our some of our guidance parameters. We spoke about that earlier in the feature with trajectory engineer Corey Buckingham. As we proceed through our launch window, there are certain points that we will reload new guidance parameters, ensure that we have an optimal flight to the spacecraft's target orbit.
LC flight control.
Go, flight control.
Contingency trajectory has been loaded using autofile FPCS Delta Victor 041-002-K_Bravo with a revised guidance STL-CRC of 5 Delta Charlie 8.
Roger.
This is Delta Launch Control at T-minus 4 minutes and holding. The team continues to work through the thermal issue I mentioned earlier. So while we're waiting on that, we'll take you through some additional shots of Launch Complex 37. This is a wide-angle shot. On the left-hand side of the screen, you can see the fixed umbilical tower with the 3 swing arms reaching over to the Delta IV Heavy vehicle. In the background, you'll see a flame. That is a hydrogen flare stack, so gaseous hydrogen that is basically evaporating from the liquid state gets burned off through that hydrogen flare stack. It's actually quite a bit of distance away from the launch vehicle, so even though you're on your screen, it may look very close to the launch vehicle. There's actually quite a bit of distance there. And then off to the right side of the screen is the mobile service tower I mentioned earlier. Here's a view of one of the Delta's onboard cameras. This camera is on the second stage looking down. And here's a closer view of the launch pad and the swing arms. On the opposite side of the vehicle, you can see gaseous liquid oxygen as it's escaping out the oxygen vents. At this point in the count, the liquid oxygen will be replenished as liquid oxygen evaporates into the gaseous format and comes out those vents as you see there on the first stage. This is Delta Launch Control at T-minus 4 minutes and holding. We continue to evaluate the thermal issue on the first stage of the vehicle and are standing by for a new T0. We've created a short tour of our launch locations here at Cape Canaveral in Florida. Let's take a look around.
With missions launched to every planet in the solar system, as well as critical national security, science, weather, and communication satellites, ULA has established a long-standing reputation for reliability and orbit accuracy in the space launch industry. At our launch site in Cape Canaveral, Florida, the story begins with ULA's Atlas and Delta rockets arriving on the RS rocket ship. The rocket ship is a specially designed cargo ship used to transport rockets from ULA's 1.6 million square foot production facility in Decatur, Alabama. Rocket ship is large enough to carry a complete Delta IV Heavy rocket. That's 3 boosters, a second stage, and a payload fairing. Once loaded, rocket ship departs ULA's dock and travels through the Tennessee River, then onto the Ohio and Mississippi rivers, then goes out into the Gulf of Mexico. From there, the ship travels through the Atlantic Ocean, around the southern tip of Florida, and north to Port Canaveral. Rocket ship was designed with several features to ensure successful delivery, including the ability to adjust its draft for shallow water and rudderless steering, which minimizes the need to tug. Atlas V boosters are transported from the ship to the high bay in the Atlas Space Flight Operations Center, or ASOC, for final preparations. Delta IV boosters are moved to the Horizontal Integration Facility, or HIF, where they are mated together to form the Delta IV Heavy configuration. With final checks completed, the boosters are transported to the launch pad for Launch Vehicle on Stand, or LVOS. The 107-foot-long Atlas V boosters are brought to Space Launch Complex 41 and are hoisted into a vertical position using a crane and placed onto the Mobile Launch Platform, or MLP, in the Vertical Integration Facility, or VIF. Delta IV Heavy rockets are raised vertically by a fixed pad erector at Space Launch Complex 37. The fixed pad erector uses a single hydraulic piston to rotate the boosters 90 degrees inside the Mobile Service Tower, or MST. LVOS is followed by the addition of solid rocket boosters, and then the second stage. Next comes Wet Dress Rehearsal, or WDR, which is an end-to-end launch simulation, from fueling through spacecraft separation. Meanwhile, the ULA team is also working simultaneously to help the customer encapsulate their payload into the rocket's payload fairing. The encapsulated payload fairing is the final piece to be mated to the rocket. With the rocket stack complete, the spacecraft team tests all of the interfaces with the rocket and the launch pad. Once the rockets are completely assembled, final launch preps begin. For Atlas V rockets, launch countdown begins with moving the rocket from the VIF to the pad. The quarter-mile trip uses 6 components to complete the 20-minute trip. Weighing in at about 2 million pounds, the MLP supports the rocket and contains air conditioning, electrical, and commodities, while the undercarriages bear the weight of the MLP and rocket. 2 rail cars lead the move, with the payload van providing communication to the payload, while the ground van houses the ground support for the rocket. At the rear of the convoy, the portable environmental control system provides air conditioning to the payload and rocket. Finally, track mobiles provide the power to move the 3.5 million pound convoy. For Delta IV Heavy rockets, the process looks quite different. Approximately 9 hours before T0, final preparations begin as 40 hydraulic cylinders at pressures nearing 3,500 psi move the 10 million pound MST. It's first raised 8 inches and then rolled back. Delta uses a carriage transporter system, traveling at about a quarter mile per hour. It takes about 25 minutes to roll the MST to its launch position, 345 feet north of the Delta IV rocket. The Delta IV rocket stands 217 feet tall, or about 21 stories, and weighs more than 900,000 pounds fully fueled. On the day of launch, nearly 30 engineers and managers are polled for system status and readiness to proceed.
Status check to proceed with terminal count, Atlas Systems, propulsion.
This is the final status check before launch for all Atlas and Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants.
Range coordinator. Clear to proceed. Launch director.
Launch vehicle is ready to launch.
Mission director.
This is the mission director. You have permission to launch.
Proceeding with the count.
If the rocket is ready for flight and the weather is within the launch commit criteria, then polling will be completed and the team will have given the go for launch.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There's ignition. And liftoff of the United Launch Alliance Atlas V rocket.
For a typical Atlas V flight, the main engine and solid rocket boosters ignite to lift the rocket off the pad. Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path, minimizing the dynamic pressure the vehicle experiences during flight. Within the first few minutes of flight, the vehicle reaches Mach 1, the speed of sound, followed by jettison of the solid rocket boosters. About 4 minutes later, propellant levels deplete and the booster engine shuts down, followed by release of the booster stage. At various times in flight, depending on the mission, the vehicle jettisons its payload fairing. From there, the second stage will continue carrying the spacecraft towards its destination with planned engine starts and stops. Finally, Centaur will release the spacecraft in its target orbit to continue its journey.
Hey guys, so I just want to come on here and say, for the updated, you can hear I got launch control on the phone. So go up to the website, bit.ly/live launch updates, update everything there, and it's starting to come on.
Conservative prediction from the models, and it generated efficient margin. Plus, looking at our flight trajectory will be mainly in sunlight, so that helps the situation as is. Our recommendation is to proceed, that we have no concerns with these current temps in the OC.
LC concurs. LD? LD concurs. MD?
MD concurs.
All right, guys. So update. It sounds like launch is go. Yeah. Let's tune in. Launch director did say that launch is
This
go.
is Delta Launch Control at T-minus 4 minutes and holding. As you just heard, the Anomaly Chief provided an out brief on that anomaly with concurrence from the launch conductor, launch director, and mission director. So in just a short few moments, we'd expect to be hearing a new T0 from the leadership team. So we'll stand by.
I got mission control on the phone and be able to hear that the microphone picks it up. Be able to hear that.
LD. LC, please coordinate a new T0 of 07:28:00. Roger, 0728. LC, LD channel 1.
New launch time
Go LD.
is 3:28.
LC, please coordinate a new T0 of 07:28:00 Zulu. Roger, 0728:00 Zulu. Good copy. ALC, please set the clock for a T0 0728:00.
Roger.
RC, LC. RC. Please coordinate with the range, new T0 0728:00.
072800 Zulu in work.
All right, guys, so you heard new launch time.
This is Delta Launch Control at T-minus 4 minutes and holding. As you just heard, the launch team is now going to target a new T0 of 3:28 a.m. Eastern Time. The assistant launch conductor will reset the countdown clocks for the new T0 while the range coordinator goes to the eastern range and verifies the eastern range can support that new T0.
LC, RC1. Go. Range is approved, new T0 072800.
Roger.
LC.
Go.
Countdown clock has been set for new T0 of 0728. We're currently at L-minus 24 minutes.
a.m. Eastern
Roger.
time.
All right, team, the clocks are set, and we have an approved T0 0728 Zulu.
All right, guys. So we got, what time is it now? 3:04. Got 24 minutes.
This is Delta Launch Control at T-minus 4 minutes and holding. As you just heard, the new T0 has been approved, the clocks are reset, and the clocks are now counting down towards a new T0 of 3:28 a.m. Eastern Time.
23 minutes.
L minus 23 minutes.
This is Delta Launch Control at T-minus 4 minutes and holding. As you can see on your screen, this is a view from the Launch Control Center at the Delta Operations Center. The team in the LCC is responsible for the final pre-launch checkouts, fueling, and launch of the Delta IV Heavy vehicle. This is the Mission Director Center, or MDC. Within the MDC, you'll find the ULA Launch Director and the NRO Mission Director, who you just heard as they received an out brief on the anomaly we have been working and then provided direction on that new T0. Here's a view from our DOSC, the Denver Operations Support Center. These are engineers that are responsible for the design and operation of the various subsystems on the vehicle. These engineers would have been engaged in the anomaly discussions and in the analysis that you heard referenced as the anomaly chief provided the out brief on that anomaly we worked a few minutes ago.
L minus 21 minutes.
This is Delta Launch Control at T-minus 4 minutes and holding. As you heard a few moments ago, the range coordinator went to the Eastern Range to request approval for a new T0. ULA collaborates with the Eastern Range to prevent launching at a time that would result in the vehicle colliding with the ISS, another satellite, or catalog space debris. Our trajectories in the launch window are provided to the Space Force for analysis prior to launch day, and we're given a report several hours before launch that indicates if launch on a given minute within the window, we'll have the rocket or payload flying near an object with a high probability of contact. This report is called a COLA report, which is short for Collision on Launch Avoidance Report. The mission director reviews the report and lets us know if there's a particular minute that we should not target for a T0. In this case, the targeted T0 was clear. Our T0 was approved, and we are counting down toward a launch at 3:28 a.m. Eastern Time.
Go.
Pulling the team now.
ULA provides the analysis used by the Eastern Range to produce stayout zones for airline pilots and boat captains on day of launch. These stayout zones prevent intentionally jettisoned rocket pieces from landing on airplanes and boats. The Eastern Range will produce NOTAMs, or notices to airmen, to indicate to pilots that the airspace around Cape Canaveral Air Force Station and along the launch vehicle's flight path should be avoided. In the event an aircraft enters this controlled airspace on launch day, local air traffic control will contact the aircraft and direct them out of the area. The range also produces notices to mariners to provide the same information to boaters. The U.S. Coast Guard will post these notices at local ports and boat ramps. United States Air Force, NASA, or U.S. Customs and Border Patrol aircraft or U.S. Coast Guard boats may intervene if boaters enter the controlled sea space and do not respond to attempts to communicate. This is Delta Launch Control, T-minus 4 minutes and holding.
L-minus 14 minutes.
14 minutes, guys.
Have a scan pattern 140. Roger. VSE, LC, no one.
L-minus 14 minutes. Has gas, LC.
Go, LC.
Establish scan pattern 140.
Roger.
Roger 6 Alpha.
VSE, LC, no one.
Set BBM pack.
50 on 1.
Verify base pending moment instrumentation is active and data is valid.
Verified active. Rep and placard 6 Alpha for launch.
Roger 6 Alpha. OS, LC.
OS.
Set BBM active.
Roger.
Personnel, check your mics on that one. Minus 12. ME2, initially retract data logger just prior to the L7 call. Roger.
All personnel, check your mics on that one. minus 12.
I have an open mic on that one.
ME2, initiate retract data logger just prior to the L7 call. Roger.
No, I don't. Oops. Sorry.
We have an open mic on net 1.
Wow. Didn't have a microphone on. Off. Jeez. Well, guys.
Minus 11 minutes. SYS, configure flume on for PU shadow mode. Roger. Flight control, configure option 910 for PU shadow mode. Roger.
minus 11 minutes. SYS, configure flume on for PU shadow mode.
Roger.
Flight control, configure option 910 for PU shadow mode.
Roger.
All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC. RC, verify solar radiation limits acceptable for launch. Verified.
minus 10 minutes. All communications switch to channel 1. All personnel and visitors remain in present
terminal count
position.
status check. The observer shall announce hold on channel 1. Identify their station. Please state the reason for the hold.
All right. So we got both channel 1 and 2.
OSM verified the whole prior switch is in the proceed position. Ready to proceed. RLM verify the red line monitor and event table are in the correct configuration for terminal count. Verified.
All right, there we go, guys.
minus 9 minutes. LC performing hold authority count check. LC RF. Loud and clear. Loud and clear as well. ATD. Loud and clear. Loud and clear as well.
Got 9 minutes.
Loud and clear? Loud and clear as well.
All right, guys.
Roger. LC switch to the ready position. All steps are complete prior to the status check.
So this audio is mission control. It is a little delayed.
LC, launch on time verified.
Roger.
So it's a little
LC
delayed.
switch to the ready position. All steps are complete prior to the status check.
Minus 8 minutes.
8 minutes. There we go. 8 minutes.
minus 8 minutes.
I don't know about you guys, but I am pretty excited.
This is Delta Mission Control at T-minus 4 minutes and holding. We remain in the built-in hold as preparation for launch continues. In a few moments, Launch Conductor Scott Barney will poll the launch team for the final go to pick up the count. 27 engineers and managers are polled for system status and readiness to proceed. This is the final status check before launch for all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Scott Barney performs the final polling of the launch team.
Status check to proceed with terminal count. Go state systems, propulsion. Go. Hydraulics. Go. Locks. Go. LH2. Go. Second stage systems, locks. Go. LH2. Go. Electrical systems, airborne. Go. Ground. Go. Facility. Go. RFFTS. Go. Flight control. Go. On. Go. JCQ. Go. Operations support. Go. Pneumatics. Go. Umbilicals. Go. Pass gas. Go. ECS. Go. Red line monitor. Go. Quality. Go. Op safety manager. Go. ULA safety officer. Go. System engineer. Go. Anomaly chief. Go. Range coordinator. Clear to proceed. Launch director. Launch vehicles ready to launch.
We're ready to launch, guys.
You have permission to launch.
Permission to launch.
About 6 minutes. MEQ, establish swing on lock and pull. Active.
We are go for launch, guys. Yes. 6 minutes. 5 minutes now. Here we go, guys.
Hydrogen tanks have been full for approximately a half hour and in topping mode to replenish commodities that evaporate while we perform final valve and vent system checks. Once the terminal count begins, you'll hear indications that propellant topping has halted on all Delta first and second stage tanks. The oxygen systems are secured first, followed by the hydrogen systems, and all tanks will be pressurized for flight. The vehicle will transfer from ground electrical power to its onboard batteries. Hydraulic systems are pressurized and the vehicle's ordnance systems are armed. At T-minus 60 seconds, the eastern range will provide the range green call indicating that weather conditions are acceptable. All supporting assets are ready for liftoff in the air and sea adjacent to Complex 37 and along the flight path.
Terminal count, guys.
At T-minus 30 seconds, launch conductor Scott Barney will conduct one final short
Launch pad swing arm has retracted. All steps are complete prior to terminal count.
At T-minus 15 seconds, the ROFIs, or radial outward firing igniters, will light to burn off residual hydrogen around the base of the vehicle. At T-minus 7 seconds, the starboard engine will
go
light,
for launch.
followed by the port and core engines at T-minus 5 seconds, and liftoff will occur at T0. After liftoff, you'll hear the voice of Patrick Moore with launch vehicle ascent data.
T-minus 4 minutes.
4 minutes.
3:55. Now pyro.
This is Delta Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
Countdown resumed.
T-minus 4 minutes.
The countdown clock is resumed. We've entered the terminal count.
3:55.
Go for launch.
We are go for launch.
Flight 325.
Second stage launch, secure at flight level.
Minus 325.
Second stage lock, secure at flight level.
Second stage liquid oxygen systems are now secured and ready for flight.
Here we go. Go, go, go.
Minus 307.
That's 249. Internal.
Minus 249.
FTS internal.
DBC locked.
2 minutes.
Pressure and flight level.
Vehicle now on internal power. First stage lock systems are secured for flight.
minus 2 minutes. Hydraulic pressure 4,000.
2 minutes.
Vehicle internal 155. Launch sequence for start.
Minus 2 minutes.
Hydraulic pressure at 4,000.
Vehicle internal.
155. Launch sequencer start.
137.
CBC LH2 at flight pressure and flight level.
Minus 140.
FPS launch enable.
137.
Minus 120. OCE's armed. FPS count started.
It's you. Start is counted.
T minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are
Guys,
go
I'm
for
gonna go
launch.
outside.
Minus 120.
OCU's armed. FCS count started.
T minus 1 minute.
1 minute, guys.
Rock, report range status. Range green. Minus 50.
T minus 1 minute.
Engine start, box scope.
Rock, report range status.
Range green.
Second stage LH2.
Minus 50.
Flight level.
All right, guys. We're good.
Minus 30. Status check. Input. NROL-44.
Second stage LH2 secure at flight level.
Minus 30. Status check.
Go Delta.
Go NROL-44.
4, 3, 2,
15.
Start the ignition.
Liftoff. Start button.
10.
9, 8, 7, 6, 5, 4, 3, 2, and liftoff. And stand by. We've obviously had a hot fire abort.
LC verifies me code confirmed.
And LC verifies MECO confirm.
And flight control looking for your call.
This is Delta Launch Control. The last call from the launch conductor indicating
E-minus 3 seconds.
that he has confirmed that the engines did not start. At this point, the launch team will be securing the launch vehicle, ensuring that all systems are safe.
3
seconds. Received a TISR
Roger.
abort.
Roger. ALC reset countdown clock to T-minus 4 minutes and only. Roger.
Roger. And are you ready to reset the clock T minus 4 and holding?
Roger, ready.
Roger. ALC reset countdown clock to T minus 4 minutes and holding.
Roger.
Shutdown and follow the reverse configuration. Active sir.
LC, FCS in pre-flight mode.
EST
Roger.
LC.
Prop 1, verify safe RS-68 shutdown and following purge configuration.
Active, sir.
Select number 4 to switch best source select number 1 and best source select number 2 course to channel 1. Roger. MET2, swing on lock pins install.
DST1, best source select number 4 to switch best source select number 1 and best Force select number 2, force to channel 1.
Well, I left my phone in here with Mission Control.
MEQ, swing arm lock pins install. And work.
Dang. Whoa, guys. Space is hard.
And LC, pad looks nominal. OSN, can you verify?
So the locking.
Right now.
Locking the swing arms in.
Roger.
And LC, pad looks nominal. OSM, can you
ALC,
verify?
establish engine cooling order off.
I was out there waiting for it. So guys, let me know in the comments. Are you guys gonna stay? What do you think's gonna happen? They still have until 6:25 a.m. for the launch window. It's a 4-hour launch window. So I'm already.
Project. And USU, you can verify that. USO verified. Roger. And MEQ, LC. Go ahead. Did you verify lock pins and so? Yes. Alright. Report system status, Field 1. Field 1 nominal. Field 2. Field 2 nominal. Box 1. Box 1 nominal. Box 2. Box 2 is nominal. And prop 1. Audio 1 nominal. And PNE, have you established PSN2? Verified. HYE, secure hydraulics. Roger. As gas established scan pattern 305. Roger. GE, establish arm igniters, reset. Reset. NE, verify nose cone purge on and set heater to 164 degrees. Verifies. OSM, LC. OSM, report ready to save vehicle ordnance. Ready. And verify OSM concurrent safe
So.
FTS. OSM concurs. FTS, command FTS safe and external. Sure.
See what the Twitterverse is saying. Oh. Not sure they're going to try to continue. So, activities to save the vehicle and ground support are putting the Delta back into the same configuration as they were at the T-4 minute hold. So, it's not confirmed.
LC, external. Roger. OSM, place room ignition switch is disabled position. Room ignition. ALC, report swing arm system secured. Secured. ALC, OTC emergency panel, remote cameras normal. Normal. PNA, configure helium supplies. In work. Off state, flight controls ready. Roger.
So they are
LC, L1.
detanking.
LDL1. LD, we had a hot fire go to T-minus 3 seconds. We have before our abort sequence securing. We are ready to proceed into detanking operation. Proceed, LC. Team, we're proceeding to Operation 80. And RC notified range of decision. RC copy. Flight control terminate option 910 and reset 910 flights. Roger.
Yeah.
And LC the one whenever. LC go. Yes, sir. Problem. Excuse me. System's not one. Roger. Optimized terminated and flight. Roger. And flight control re-enable MSE Adams limit monitor. Roger. MSE limit monitors are enabled. Roger. RLM LC. RLM, go ahead. Stop red line monitor. Roger. LC flight control is ready for flight. Reset T+5 minutes. Roger.
So we got a T5 minutes.
ALC clock to T+5 minutes and start bus count. Roger. And gas LC. RLM stop. Roger. As gas, speed scan pattern 305. Roger. And ME2, we've already established swing arm lock pins installed. Roger. Shut down swing arm hydraulic system. Roger. Installed. Roger. Shut down swing arm hydraulic system. Roger. OSM LC. Also, Step 70, drop FHA roadblocks and establish PDA roadblocks. Roger. OSM SRM ignition disable. SYS LC. Establish T or PCM data transfer to Anomaly per dick.
So guys, we have the clock set at +5 minutes. Abort happened at 3 seconds and do not have a new launch time. If there is going to be a launch. The window, there's a 4-hour window starting at 2:04. So it is now 3:41. Still have a couple hours in the window. So if the problem, a hot fire abort at 3 seconds, if whatever caused that, they can get it fixed within the window. Now they are detanking now, so they're taking all that liquid hydrogen, liquid oxygen out of the tanks. So, I don't know. It takes about 30 minutes, I believe. 20, 30 minutes. After that, scrubbed.
Activities will not continue this morning, and a new date has yet to be identified. For the most up-to-date information, please visit ulalaunch.com, follow us at ULA Launch, or call 1-877.
All right, guys. So it's been officially scrubbed. That's.
Thanks for using WebEx.
Thanks for using WebEx. Okay, guys. Yeah, scrubbed. Oh no. And stay tuned. bit.ly or just go to the talkatitusville.com/ space talk, or go to spacetalk.live. Follow all the updates, and we'll see you guys Sunday. Sunday there is a 10:04, 10:08. Keep moving the times. The 10:08 launch, and then the same day at 7:19, they'll be launching another one. So Sunday we have 2 launches, one at 10 and one at 7:19 p.m. 10 a.m. and 7 p.m. So stay tuned for that. It's going to be exciting. And be safe, guys.